Okay, now we'll be talking about bits and bytes. Remember in the first section of lesson 4 I told you that we'll be speaking about data and how data is stored. And if you remember from the time that we spoke about the binary code, we said that there are only two symbols in binary, and those were 0 and 1. But despite that fact, we said that we can represent more codes than just two by combining several bits. So this is going to be also a clue for one question of your previous homework, but that's okay. If I draw here, let's say, a box with 4 bits, each box here has the capability of carrying either 0 or 1. For each one, 0 or 1. So how many combinations of codes can we store in those 4? The answer is simple. There are 2 possibilities here, and 2 possibilities here, and 2 possibilities here, and the same in the 4th one. So in order to calculate how many possibilities we have for all those 4s, we simply multiply 2 times 2 times 2 and the 4th time. And if you do the math here, you'll get, I'm sure you guessed it, it's 16. So we can have 16 different types of codes represented with those 4 boxes. For example, the first one, I can say all zeros, and the second ones I can say this one is 1, and those 3 are zeros, and the third one I can say that this is 0, this is 1, and these are zeros. And I'm sure that by now you already are able to list all the possibilities, which are 16 different possibilities, so 16 different codes. And we also spoke about something that's called byte, and we said that byte is made of 8 bits, right? Byte is equal to 8 bits, and therefore how many codes we can store in 1 byte? We simply multiply the number 2 8 times, which is the same equivalent as 2 to the power of 8, we call it. I don't know if you learned powers in school, but 2 to the power of 8 means 2 times 2 times 2 times 2, 8 times, and this will give you 256. If you don't believe me, you can calculate it, but you'll get the same number, 256. So let's see what's the importance of bits and bytes. The first thing is, we said that we can store in a byte, we can store a character. Remember? Character. Let's draw a box. A character could be a letter, like A, or it could be a symbol, like $, or it could be a digit, like digit 4, or anything that's on your keyboard is considered a character. And we can represent a character with 1 byte, because there are 256 possibilities for different codes that represent the character. And we already spoke about this, so you should be quite familiar with the concept of bits and bytes. And now we'll take it a little further. Let's talk about storage capacities of disk. if you buy a computer and they tell you that the disk drive comes with 80 gigabytes, what does that mean? So we already know what the byte is. So now we'll try to decipher what a gigabyte is. So let me go to this. And we said that 1 bit is 1 binary digit, and then 8 bits is 1 byte, right? So far we know. Now the unit of 1024 bytes is called 1 kilobyte. Why is it 1024? 1024 is a multiplication of 2. So if you multiply 2 by 2 by 2 by 2 10 times, you will get the number 1024. So in other words, 2 to the power of 10 will give us 1024. Now, in the world of computing and operating systems, they use this number, this 1024, as the kilo, the measurement that's called kilo. Kilo in real life is usually 1,000. For example, 1 kilometer is 1,000 meters, or 1 kilogram is 1,000 grams. But in the world of computing, they use the number 1024 instead of the number 1,000, and this causes some confusion, and we'll see what the confusion is a little later. But for now, let's go back to our chart of bits and bytes, and as we said, 1024 bytes are called 1 kilobyte or 1K. The next level up is going to be 1024 kilobytes, and that's going to be 1 megabyte. The next level up will be 1024 megabytes, and that's called a gigabyte. And gigabyte is what we measure usually hard drives with. So if you multiply 1024 times 1024 times 1024, it will give us the number of bytes that are inside 1 gigabyte. And I can tell you that in 1 gigabyte we have approximately 1 billion. It's not exactly, because every time we multiply by 1024, not 1,000, and it's just approximation. So this is how you write a billion. I hope you know it's 9 zeros. So this is approximately 1 gigabyte. Not exactly, and the part of your homework will be to multiply the number 1024 times 1024 times 1024, which will give us what the operating system sees as 1 gigabyte. And after you get this number right, you send me that number in an email, and we'll talk about the difference between 1 gigabyte as the computer sees it versus 1 gigabyte as sometimes people talk about, which is 1 billion bytes, and why it's causing some confusion. And the confusion will be when you buy a disk of 80 gigabyte and you check the size inside the computer, it will tell you that it's approximately 74 gigabytes, but not 80, even though the manufacturer said it's 80. And the reason is because of this difference, and we'll talk about that in the next section because we're running out of time. And that's it for this section for right now.